Okay, we're graphing systems of equations. When we graph the systems of equations, before we can really graph them, they need to be in y equals mx plus b form. That is a linear equation. It's the slope-intercept form, and so it gives us an opportunity to know where the y-intercept is at and know what our slope is so that we can graph it. So let's get right to it. On these two equations, they have to be set in y equals mx plus b. So what we're going to do is we're going to take the first of our equations and we're going to skip some steps. Hopefully by now you can take these shortcuts and it makes some sense to you. So if we say negative y equals, we're taking the 2x and moving it to the other side. When you change sides, you change signs. So that's negative y equals negative 2x plus 8. Now, we want that to be a positive y, so what we need to do is actually divide through by negative 1. So what we're going to do basically is change the signs on everything. That's what dividing through by negative 1 does, is it changes all of the signs. Remember, if you do one thing to one side of the equation, you have to do it to both. So the equation has to be what we call balanced. So we have y equals 2x minus 8. So that's how it changes up once we divide through by that negative 1. Okay, let's deal with our other equation so that we can get ready to graph. And so this one will be a little bit more simple as y is positive already. So it's y equals negative x, remember that's negative 1x plus 1. So now we have both of our equations. Let's start by graphing our first equation. Well, actually, we can graph either one of them. So we're going to use our first one. We know that this is our y-intercept, so our y-intercept is at positive 1. We have a negative x, so it's down 1, right 1. And so we continue that pattern of down 1, right 1. And notice I'm just putting the dots here. You would normally make the lines when you do your assignment, make those lines so that you can clearly see that it is a line that continues, but it has one point in common. So I'm going to put arrows at either end so that you know that continues. The reason I left it as points or dots on that graph is just so that you could see the common point where these two will meet. So let's take a look at our second equation, which began at negative 8. And then our slope is 2, so we rise 2, go right 1. We'll continue that trend, and when we do, we see that that is our common point. Again, I'm going to put the arrows out here just so that you are reminded that that is a line that continues on. It just happens to have that one point in common. So that one point that we see that it appears to have in common is at positive 3 on the x, negative 2 on the y. So we're going to put our ordered pair here. Now it's not complete until we actually check it. We have to put it in back into both of our equations so that we can make sure that it fits both. It must fit both in order to be a correct solution. So first of all, we have 2 times our x value, which was 3, minus our y value, which is negative 2. Remember, that's minus a negative. That should equal 8. So we see that 2 times 3 is 6. Negative times a negative is positive, and 2 plus 8, that gives us 8 equals 8, and that is a true statement. Now we need to plug it into the other one to make sure that it works for both. So our x was 3 plus our y, which is negative 2, equals 1. 3 plus a negative is a negative. 2 equals 1. And we see 3 minus 2 is 1 equals 1. That is a true statement. So our correct solution there is 3, negative 2. The point 3, negative 2. Taking a look at number 2, let's deal with our equations as we put those in y equals mx plus b form. Our first one is going to be y equals negative 2x plus 2. And then our second one is going to take a little bit of work. It'll be a negative y equals, remember, change sides, change signs, negative x plus 4. We need to make that a positive y, so that's going to be y equals x minus 4. So it did change a little bit as we move things around. So let's graph our equations now and see if we have a solution. We start the first one at positive 2. It has a slope of negative 2, so negative 2 is minus or down 2, right 1. We're going to graph that out. Go back the other way. Remember to put, I'm putting those arrows on there to remind you that it is a line that continues. Then we have our second function, which starts at negative 4. And it's a positive x, so it rises 1, right 1. That's our common point, or our point of solution. And we just continue up the graph. Just a reminder that those continue. So what we got is a positive 2 on the x, a negative 2 on the y. Let's see if those are correct. So our first equation was 2 times our x value of 2 plus our y value, which was the negative 2, equals 2. So 4 minus 2 equals 2. 2 equals 2, that's correct. And then we have our x value on our second equation, which is 2, minus our y value, which is negative 2, equals 4. So 2 minus a negative is positive. 2 equals 4. 4 does equal 4, so that's a true statement. And our solution is positive 2, negative 2.